So this is overexposure, which is complying with the May 3rd, 2033 FCC regulation that went into effect May 3rd, but it was in works for at least 2, maybe 4 years prior to that. So what happened is the FCC went through their regulations and they took a bunch of regulations that were specific to different radio services and said, we're going to combine all this into one set of common regulations because RF is common. It doesn't matter whether you're in the Marine service or the amateur service, the broadcast television service, where they had all these different regulations. As part of that, they took out some categorical exemptions, one of which affected ham radio, which said if you're operating under a certain power limit, you don't have to worry about it as long as you don't expose someone to excessive RF energy. They didn't change the technical side. Physics hasn't changed. Imagine that. Physics, change review board for physics has not met in eons. The RF exposure limits still must comply. They haven't changed. You still have to comply with the FCC rules. And all the way we used to do evaluations, they're still valid. So the big change was we're no longer categorically exempt because we're ham operators operating under some power level. Let's go to the top of this slide because it's kind of important. So what's the problem with RF exposure? The biggest problem is that too much, too fast will literally cook the human body. It has the potential of causing heating, but it can be operated safely as long as you don't stand in front of the microwave oven with the door open. So we have to perform a station evaluation. We're no longer exempt, but it's easy. And I'll show you how to do the exact evaluation. If you modify your station in a way that affects the RF exposure, you have to repeat the evaluation. So the good news of all of this is most likely your station doesn't have a problem. You just have to do the evaluation to show that it doesn't. And when you do the evaluation, you're just going to take that evaluation and say, that's very interesting. I'm safe, my family's safe. I'm going to put that in the filing cabinet so that if somebody ever asks, I've already done it. And you sign the Form 610 that says we will comply with the regulation. The FCC doesn't want to see it unless something goes awry, and they will let you know. So RF exposure safety, I broke this down into two parts because the primary part is about RF exposure density over time. And the exposure density is a function of how much RF power you're pushing out, what your modulation duty cycle is. This is the way the waveform of your particular mode is leaving that transmitter. CW is an on-off. It's on sometimes, it's off sometimes. FT8, here's my FT8 aficionado, this one right here. Once he starts transmitting, it is full scale, putting out for however long it is, and it just stops. FM, AM, the digital modes are all that 100% modulation duty cycle. The lower duty cycle modes are CW and single sideband. I've got the modulation percentages up there. Another duty cycle that often causes confusion is the one between how much do you transmit and how much do you receive. So if you get on your 2-meter rig and you talk for a minute because you're part of a net and it was your turn to talk, and then you're silent for 10 or 15 minutes, your duty cycle is 1 minute transmit, 10 or 15 minutes receive. That's a different duty cycle than the modulation duty cycle, which is while you're transmitting for FM, it's 100%. We'll see that in a few minutes. How far you are from the antenna affects the RF exposure density, and the antenna gain and radiation pattern relative to where you are measuring it also affects that density. But it's also about frequency. The higher you go up in the frequency, the higher the potential biological damage. So you get to about 70 megahertz, and that's the sweet spot for the human body. That's where the maximum rate is, where the body will absorb RF energy. And if you absorb too much energy too fast and you can't get rid of that thermal heat, that's when damage occurs. So there's a bunch of key terms. Effective radiated power, you've seen that before. Maximum permissible exposure, that's how much of a particular range of frequency that the human body can handle. It's expressed in terms of a power density, and it's also got electric and magnetic field strength numbers. It applies when you're more than 8 inches away from the antenna. And the FCC's got a bunch of rules that talk about MPE. The other way is specific absorption rate. This one is a little different. It's how fast does a specific element of the human body, the tissue, an organ, or your eyes, absorb RF energy at the specific frequency. This is a complex way of doing things. It's difficult to measure, it's difficult to model. Most hams do not have the skills and the education background to deal in SAR. I certainly don't. You'll also see a term called positive access control. Positive access control is a way of preventing people from getting into the area where there might be RF exposure. You've seen this, you just didn't realize it, out around the airport. You might see an antenna tower, a rotating doodad on top, and some placards around that talk about RF exposure and hazards. That's a positive access control because it's most likely behind a locked fence. They don't want you up close to their radar. But there's two definitions down here that really apply to us that are easy to talk about. One of them is the minimum compliance distance. This is how close you can be to the antenna and still be within the RF exposure limits. We'll talk about that because that's the number that comes out of the little calculator we're going to run. The other definition we need to deal with is controlled versus uncontrolled space. So controlled space is an area that you have control of. So at your house, it's typically your backyard because you have a fenced backyard that keeps the dog inside, and your antenna is in the backyard. So that's a controlled space. You control the access. You and your family know there's an antenna back there that radiates energy. You can do the math and say this is how much the minimum compliance distance is for the controlled space, how far away from that antenna I need to be when it's emitting. And you can limit your station operation to times that you know nobody's around that antenna. So that's the controlled space case. When we do the math, they do the math computed over a 6-minute exposure period. And that's important because in the uncontrolled space, they do it over a 30-minute exposure period. So uncontrolled space, this is space you have no control over. It's your front yard because you don't have a fence in the front yard, but you might have a flagpole antenna in the front yard, and some passerby on the sidewalk might just walk right by it, not knowing that's an RF radiator that's putting out RF. Public streets, alleys, the other side of your backyard fence is an uncontrolled space because it belongs to the neighbor. General public is unaware of RF exposure risks to the most part. They may not be aware that you have equipment that radiates RF, and they certainly don't know these terms of minimum compliance distance. So how do we figure out this minimum compliance distance? The gurus that are behind all this RF safety stuff have come up with a website that's on ARRL. There it is up on the screen. And it's an online exposure calculator. It's real easy to do, and the easy way for us to use it for starters is go into that calculator with a bunch of broad assumptions. Let's assume that our transmitter is a 45-watt, 2-meter all-mode rig, and let's assume we've got really good coax. All that energy goes out to the antenna. There's no loss in the feed line because it just makes the math easier. Let's use the ARRL numbers for duty cycle and antenna gain for the type antenna we're using. And we're going to turn on the switch for evaluating ground reflections because ground reflections get into how much RF is out there. And this calculator is going to compute two numbers for us that we're paying attention to. It's the minimum compliance distance for controlled space and minimum compliance distance for the uncontrolled space. And here is the calculator. I went to the website. It's a long page. I captured the top part of the page, which says, enter your data here. It's real easy. There's my 45 watts. I dumped it into the cell there, and I just used the maximum rig power because it's easier to start with. If you need help filling that in, you just click on this and there's a little pop-up that'll come up that'll help you with it. Tell him what mode you're operating. We're FM, so our modulation duty cycle is 100%. We're going to transmit for 2 minutes, then we're going to receive for 10 minutes. This can vary depending on what you're doing. If you're in the middle of a net, it's not going to be that much. You're gonna check in, and then you're going to listen to Steve for 10 minutes. But I used 2 minutes and 10. If you get a higher ratio, you get a more conservative result. If you talk for 10 minutes and you don't listen, well, that's going to be 100% transmitting, and your number is going to be awful. Antenna gain. I put in 3 for mine. I've got this is for a J pole that's sitting on top of my roof, and it operates on, gee whiz, the KB5A frequency. Antenna gain, you can click on that little thing, a little table will pop up and say, in general, if you have this kind of antenna, the gain is probably about this. And then I turned on the include effects of ground reflections because you get a more conservative result. And we're trying to be conservative. We hit the calculate button, and it does its math in the background. It applies all the rules that the models know about and spits out a couple of numbers. We're interested in 2 of them. For a controlled environment, our minimum compliance distance is just over 2.5 feet for this particular example. For the uncontrolled environment, it's just over 4 feet. So on the right-hand side, I've got a little explanation of what's going on. My J-pole antenna is on my roof. It's roughly 14 feet above ground level. It's roughly 8 feet above my head. And I'm in controlled space because I can control where I stand relative to that antenna. So I have to be at least 2.6 feet away from the antenna and still be compliant. Assuming my family is 6 feet tall, we have plenty of margin, we're compliant. Let's go to the uncontrolled situation. The antenna is about 12 feet laterally inward from the edge of the house where my driveway is. See, driveway, brick wall, antenna is about 12 feet that way, laterally, and 14 feet up. Do a little math with some triangular distance, and you can figure out if the neighbor is leaning next to my house, he's about, and assume he's 6 feet tall, he's about 14 and a half feet from my antenna. The minimum compliance distance computed by the calculator is 4.4 feet. As long as he can't get closer than 4.4 feet, I don't have a safety concern. If he climbs up on the roof, that's a different matter. If I get up on the roof, that's a different matter as well. So the good news for this particular example, nobody can get close enough to that antenna to have an overexposure situation. Now this one I took for my J-pole in a particular position, running on a particular amount of power, running FM, and the other variable frequency. So I ran that calculator for a bunch of different numbers, and you can't read all of these, but that's just the list that I ran. This is tabular form, the same thing. Case number 1 is the J-pole that we just took, which says that as long as we stay 4.4 feet away from it for uncontrolled space, we're good. Next one down is my trap vertical antenna, and 40 meters. Because it's ground mounted, it's got a little bit different numbers to it. I assumed that my rig puts out 100 watts. I'm in CW, so my duty cycle is 40%. I'm going to transmit for 2 minutes, and I'm going to listen for 10. That's just a handy number. And my gain on my antenna is 1.5. So run the numbers through the model, and it says For the controlled space, I need to stay at least half a foot away from the antenna. Okay, so the dog can't get within a half a foot of the antenna. That's okay. Most of the time when I'm operating, the dog is right about there at my feet, wanting to be rubbed. My neighbor, which is in uncontrolled space.
It's on the other side of you wanting to be rubbed?
No, no. He needs to stay at least 0.8 of a foot away. So do the math real quick. Less than a foot away from any portion of that antenna that's radiating. And my closest neighbor to that particular site happens to be a ham operator, so which adds in another variable, but we're not talking about that. So I don't have any problems with that one. Let's go down to case number 3. Let's go to 20 meters. Let's run a dipole. When I run 20 meters dipole in the backyard, it's up about 20 feet strung between a couple of trees. Let's go play sideband. Still got 100 watts. Run the math. It says I've got to stay at least 3/4 of a foot away from that antenna that's 20 feet in the air. Well, that's not a problem. And my uncontrolled space requirement is 1.3 feet. I should point up here, sorry guys. I should bring my pointer. 1.3 feet. So my neighbor has to stay at least 1.3 feet away, which means my dipole really can't go over the top of his fence and be right there about head level. That would be bad. But that's okay because it's in my backyard, strung between 2 trees in my backyard. And I got plenty of space between those trees and my fence. So I'm good.
And your antenna is 20 feet above ground.
And it's 20 feet above ground, so he'd have to get the ladder out to get up there next to it. So we run a bunch of these numbers. I did a bunch of them at 20 meters. I did an FT8 because David likes FT8. That's case number 4. When you run FT8, you don't run 100 watts. So you run about 20 watts, and that sometimes is too much. You have a 100% duty cycle on the mode, but you're not transmitting that long. Ooh, a pointer. A green thing. So there's our case number 4. So we got 1 minute to transmit, 5 minutes to receive. I just pulled those numbers out. We're using a dipole. It's got a little bit more gain than my vertical antenna. But look at the numbers. I'm still controlled space half a foot, uncontrolled space just over a foot, and I'm up 20 feet in the air. So that one's not a problem either. David, does yours have a problem? No, it doesn't have a problem. So let's see what we can do about making a problem. Let's go pull that linear out and go put 1,000 watts towards that antenna. On 20 meters, we're going to use sideband. And the numbers say 2.3 feet for the controlled space and 4 feet for the uncontrolled space. I'm still 20 feet up in the air, so I still don't have a problem unless some 12-footer or 16-foot kid shows up in the backyard. Not going to happen. Let's go a little further. 6 meters, because David likes 6 meters. And we're still going to keep that linear running. Sideband. And now we're getting up there. The uncontrolled distance is now 8.5 feet. Well, the frequency went up. We're now at 52 megahertz. We're getting into that part of the band between 30 megahertz and about 300 megahertz, if I remember correctly, where the human body is more sensitive to RF radiation. So our distance has to be further. I took that same situation but moved it down to 10 meters, 30 megahertz, 28 megahertz. I've still got similar numbers. That just shows you what's going on with the frequency. And then my last case down here is the Tom Yini case. He got on 10 meters on the 3-element Yagi up at 50 feet in the air, running 1,000 watts on sideband, just making contacts left and right. And the controlled space is 9 feet, and the uncontrolled space is almost 16 feet, but that antenna is 50 feet up in the air, so he doesn't have a problem. So I ran this case assuming a bunch of different antennas and situations. And this is what you have to do for your station. Make a list of your favorite modes, how much power you're running, which antennas you've got, the characteristics of your antennas, and run the calculator and see what happens. So once you got the distances, you start measuring where that antenna is relative to the uncontrolled space, because that's really where things are critical. Your family, you can deal with. We'll talk about the family in a second. If your fence is further than that minimum compliance distance, then you're good. You've done with the math. All you have to do now is talk to your family about RF exposure, because you don't want the kids, playing ring around the rosy around your vertical antenna. That's bad. You don't want the dog out there. The cat's going to do what it's going to do. It's a cat. Protect your family and pets. One way of doing it is don't operate when they're out there. Another way to do it, you could just put a little picket fence around your antenna. A couple of feet out, depending on what the numbers are, it works. If that minimum compliance distance is in your neighbor's yard, step one, don't panic. Step two, do a more detailed evaluation. You know that trick where I said, let's just assume that my 45-watt rig at 2 meters got all that RF out to the antenna? Well, we know that didn't happen. It's got coax in the way. Go out there and figure out, it's 100 feet of coax, it's got this much loss per in dB per 100 feet. Go adjust the numbers so that the power at the antenna, which is what the calculator wants, is correct. Check your data entry. Did you put the decimal place in the right place? Did you use the correct number and not some other number? Did you read the number in meters and say, oh no, I'm too close, and the number's in feet? We talked about computing how much power is really getting to the antenna. Did you use the right modulation duty cycle? That trips people up. Did you really talk that long? You didn't talk 10 minutes and listen for 0. And how much gain does your antenna really have? Now, if you start down the road of how much gain has it got and start playing with the lobes, you're going to be doing a lot of math with that calculator. You won't do the math, the calculator does the math, but it's a lot of test cases you have to run through. But as you can see, it's not real hard. We ran a bunch of test cases and we didn't have a problem. So Alan, do you have a question?
Well, statement, when you ran the beam antenna,
yes.
That compliance distance is in the direction the beam is pointing.
Yes, it is.
If you're behind the antenna, the compliance distance is much, much shorter. That's always worst case on the beam.
Right.
Which way is it pointing? It basically says, don't point at your neighbor's house. If your neighbor's house is
15 feet of your yard, and you're running your linear at the time.
Right.
And your second floor of your neighbor's house is at 50 feet. So on a beam, and a lot of the way I did this, even on the dipoles, I used the worst case of the gain and assumed that the antenna had that much gain in all directions, even though we know that if an antenna has gain, it's because it's shooting more out that direction so that it's shooting less out this direction. You kind of squeeze in that balloon. There is this odd exemption in the FCC rules that says that if you're beyond the wavelength over 2 pi, the special set of rules kick in. And I didn't dig down into this because it takes a lot of digging down to figure out if you want to use that exemption. It's in the RF safety chapter of the ARRL handbook right at the tail end. I have a copy up here if you want to look at it. And it's online. You don't even have to buy the book, the handbook. You go to the RF exposure website, they extracted this and put it out there for your reading pleasure. Keep on going. You still have to comply with the exposure regulations. There's no exemption from that. So how do I limit my RF exposure? If you have a problem, first thing you can do is reduce the RF power. So say we can't live with that 1,000 watts coming off the antenna. Let's go back to 100 watts. How much power do you really need? Can you make the contact with less power? You could change the modulation duty cycle. Now, if you're an FT8 aficionado, then you're not going to want to go run CW. So maybe that's not an option. So maybe you reduce how often you transmit. So, okay, I'll stay on 10 meters because I love 10 meters, but I'll do more twirling around. Oh, I've already talked to that guy. So instead of once every 5 minutes, it's once every 10 or 20 minutes. I reduce how much time I'm actually transmitting or distance between transmissions. I can change the operating bands. So 10 meters or 6 meters is bad. Maybe 10 meters, I could stay within that minimum compliance distance and still have fun with FT8. I'm picking on FT8 up here. You can put more distance between the antenna and the people. You move your fence and make your controlled space larger. It might not work. You can put the antenna higher, as we saw. If you get that antenna up 20 feet, then that kind of solves a lot of your problems. You probably need to get the antenna out of your attic. We'll talk about that in a second. You might justify going and getting that tower. That solves that problem. Move the antenna further from the neighbor's yard. So if you've got the antenna off to the side, well, maybe that's not the best place to put it if the pattern is such that that minimum distance is right at the fence line or just over. And maybe you need to say, I need to move that antenna out to the other side of the yard. A variation of move the fence. Or maybe you decide that antenna really is not cutting it. I need to use a different antenna for that particular frequency so that I can stay within that minimum compliance distance. You can also limit your operating hours. Okay, I'm not going to operate in the afternoon when the kids get home from school because they're in the backyard playing on a swing set. I'll wait until 10 o'clock at night when they're in bed. And the last little banner, it's your responsibility to make sure that nobody is ever exposed among that above that maximum permitted exposure. Oh, here's a goodie. If you go out to the park, Kevin, I saw Kevin come in. Hi, Kevin. We need to know what we're doing. We need to have a minimum compliance distance for that antenna that we took to the park, for that G90 radio we're using, and make sure nobody just comes and says, oh, what you guys doing? And walks their dog through the antenna while you're transmitting. We need to do that for field day too. And yes, we did. I had a chart for field day that said, these are the antennas, these are the bands, this is how much power we're going to do. We're not going to have a problem. You can do this the easy way for the park operations or field day because you typically take the same antenna or a small subset of antennas. You typically take the same rig. So go run the math at home for the test cases. You're going to run 20 meters, you're going to use FT8, whatever you're going to do. Make a chart, like I made a chart. Put the chart in your go bag, and then when you get out and set up so you can watch the antenna. Maybe you put some yellow tape around the antenna area to kind of outline where people shouldn't be. Or you raise the antenna so nobody can get inside that minimum compliance distance. And be sure somebody does the field day numbers. Some gotchas. My favorite gotcha because it's, oh, that's a problem. If you've got a vertical ground plane antenna, you got really two legs of that antenna. One of them is the vertical, the other is all those radials. When you compute the minimum compliance distance and you start measuring it, you need to measure it from both of those elements. Well, the 1 foot away from the vertical stick is easy, that's not a problem. But you need to take that 20 feet worth of radial and add a foot to it and see where that lays, because that radial is part of the antenna. Minimum compliance distance for a dipole, that's generally, if you think of it, it's like a 3D sausage or a hot dog, all the way around that antenna, three-dimensional. Unless you want to consider the lobes of the dipole. But if the numbers work like they do for mine, you don't have to worry about it because you're inside your controlled space anyway, and it's up 20 feet in the air. My 2-meter ground plane antenna on the roof. It's a J-pole. It has a little bit of radiation pattern down into the house. But let's assume that it radiates equally down into the house as it does outward, which is not the way it works, but let's assume it does. You want to make sure that none of your family is below that antenna, inside that radiation pattern, and inside that minimum compliant distance. So you may have an unexpected RF exposure going on depending on where that antenna is. Likewise, if you have a dipole antenna in the attic or a fan dipole in the attic, you could have a similar problem. So be sure to take that into account when you're considering your compliance to the RF exposure regulations. What's next? What about my HT? So your HT is typically about 8 inches or so from your head if you're lucky. And 8 inches is that magic number where the FCC says, and all the physicists say, you really ought to be doing a specific absorption rate analysis. Well, that's a little bit beyond the skills of most hams. So the FCC came in and said, we want the manufacturers to tell us what's going on relative to RF exposure for that radio with that antenna with that much power, because it's typically 2 meters. They know what the frequency is. And anyone that purchases that radio is typically going to have the same problem. So why don't we let the manufacturer do it and certify that that's what's going on? So they did a survey of some commercial handheld rigs with similar power levels to the 2-meter handhelds that we use. And they were at the frequency right above 2 meters, so it's a relatively close frequency. And they found that those did not cause an overexposure risk. They did another survey of some commercial HTs running similar output power with rubber duck antennas and found that all of those were below the FCC SAR limits. So basically we can hang our hats on the commercial world has done this analysis, the manufacturers have done this analysis, and the data seems to indicate that our HTs, as long as we're using that little lousy rubber duck dummy load, you can laugh now, that rubber duck antenna, which doesn't radiate particularly well, it doesn't cause us an RF exposure problem. Any questions on that or comments from the peanut gallery? Sounds good. What's next? Where to go for more information? You start at this webpage here, ARRL.org, RF exposure. Everything else that's on this slide you can get to from that website. It's got the RF safety section of the handbook, which I have a copy of up here.
Which year?
I don't know which year that was. This is 2023. And it was written by this Greg Lappin, who was the chair of the ARRL RF Safety Committee.
He must be right then.
He must be right. He's got these letters called PH and D after his name, piled higher and deeper. Yeah, I think he knows what he's talking about. He wrote an article in the May 2023 QST talking about RF safety. That's apparently his field of expertise. FCC has a bulletin called OET Bulletin 65. You can get it free here. That was largely written by the ARRL RF Safety Committee. You got the RF safety section of the ARRL antenna book, which the same guys put their fingers in that. The ARRL years ago published a book called RF Exposure and You, and they sold it. But it's out of print. And now they've decided to put it up on a website. You can download it and read it. You just have to realize that text has not been updated relative to the FCC rules. So it'll tell you one thing about the rules, and well, that's not the way the rules are written now. But all the math and the examples for how to figure out RF exposure safety, all that stuff's still good. That thing's about 300 pages. It's got lots of charts and graphs and data that you can just go get buried in.
Thank you,
fast.
Ron.
You're welcome.
Thank you.